Hello, this is Dr. Eddie Morgan over at Clovis East High School, and we want to get started today working on our Unit 9 review so that we're ready for our test. In the first problem, it says the diameter of a circle Z is 12 inches. What's the area in terms of pi? Well, first of all, to find the area, we need to find the radius. Notice that the circle does not give us a radius, it gives us a diameter. But we know that the radius is half of the diameter. So we can plug in the diameter of 12 for D, and we get that the radius is 6 inches, half of 12 inches. Now we can use our formula for the area with radius to find our area. So area is pi times r squared. So we substitute 6 in for r, and we get pi times 6 squared, and 6 squared, 6 times 6 is 36. So our answer is 36 pi square inches. In problem number 2, they give us the radius this time, but they want to find the circumference of the circle that has a radius of 5.2 meters. And again, they allow us to express our answer in terms of pi, so we don't have to estimate it. So let's take a look. First of all, let's just use our formula for circumference, which is the circumference equals 2 times pi times the radius. Our radius is 5.2, so we'll simply substitute 5.2 in for r in our equation. And now we just simplify. 2 times 5.2 is 10.4 pi, and our units here are meters, so our answer is 10.4 pi meters. In problem 3, they tell us that the perimeter of the square is 24 meters. They want to find the area. Now, what they're going to do is this is going to be a two-step problem. We're going to use the perimeter to find out what the side of the square is, and then we're going to use the side of the square to find the area. So first, remember that all 4 sides of a square, we'll call the sides S, are equal. So the perimeter is the sum of all 4 sides. So S plus S plus S plus S, or 4S, is the perimeter, and they tell us that the perimeter is 24. So when I substitute 24 in for perimeter, now I can solve to find the side of the perimeter. Divide both sides by 4, and we find out that the side is 6. So 6 meters is the side of my square. Now that I know that, I can find the area. Remember, the area is base times height, but in a square, the base and the height are exactly the same. So base times height is just side times side, or side squared. So that we'll plug in our 6 meters, and we get 6 squared, or 36 meters squared, and that's our answer for the area of the square with a perimeter that is 24 meters. In problem 4, they give us the coordinates of the 4 points of a parallelogram, and they want us to find the area. Well, first off, we just need to plot the points. So from this point here, -1 left, -2 down, gives us our first point A. B is from the origin, again, always start at the origin, 2 to the right and 9 up will be the point B, 2, 9. C is 7 to the right from the origin and 9 up. Notice it's on the same level with B and C, are the same horizontal level. And then D is 4 over and 2 down. And again, that's also on the same horizontal level with A. Now if we connect the points, there's our parallelogram. Now we just need to remember that the area of a parallelogram is base times height. So I need to draw a perpendicular from the top to the bottom, and I can just measure that. The height, if I count the squares, is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Or if I wanted to do it with the numbers, I could use the y exponent. 9 minus 2 is 11. And then the base, just counting that, 1, 2, 3, 4, 5. So that's 5 units there. Again, I could use the x exponents there. 4 subtract -1 is 5. And now our area is base times height, so it's 5 times 11, and it's 55 units squared. Number 5, we're asked to calculate the area of a triangle. The area of a triangle, remember, is 1/2 base times height. I can see the base is 36 inches, but I don't know the height. So what I'm going to have to do is to find the height, is I'm noticing that this triangle is made up of 2 smaller triangles. So I'm going to use one of them, and I'm going to use the smaller one over here, and I'm going to use this one on the right, And I can see, since the 38 is split in half, that this side is 18, this side is 18. I know that because this is an isosceles triangle, and since they're both 30, these two sides will be split in half. So now I can use my Pythagorean theorem to say a squared plus b squared is c squared. In this case, the hypotenuse 30 squared is going to equal h squared plus 18 squared. So we multiply that out. 900 equals h squared plus 324. Subtract 324 from both sides, and we get h squared equals 576. So h is the square root of that to unsquare it, and we find out that h is 24 inches. Now we can work our formula. So now we plug in for the base, 36 inches, the base of the whole triangle, and the height is 24, and we have 18 times 24, or 432 square inches is our answer. Number 6, find the area of the trapezoid. The trapezoid formula is 1/2 the height times the sum of the bases. So this is simply a straightforward plug and play problem. Plug in what you know. My height is 14 centimeters. My base and my two bases are 12 and 28, so add those together. So I get half of 14 is 7, 28 and 12 is 40, and 7 times 40, 280 square centimeters. Problem 7 asks us to find the area of the polygon. As we look at the polygon, we can see that it is a kite. And we remember that the area of a kite is 1/2 the product of the diagonals. I always think of a kite and imagine a rectangle around the kite, and realize that the kite fills up exactly half of that area. So it's half the base times the height of the rectangle. But first we got to find out what the diagonals are. Notice they're split into two pieces, so we simply have to add them together. This one is 10.5 plus 14 plus 5, or 25 meters. The next one, they're both 8, so 8 plus 8 is 16 meters. And now we can plug our two diagonals into our formula. 1/2 of 25 times 16. I'm going to do 1/2 times 16 first, because I can do that in my head, is 8. And 8 times 25 is 200 meters squared. And so my answer is the area of the kite is 200 square meters. Next one, we find the area of a rhombus. A similar problem to last time. First thing we're going to do is realize the area of a rhombus, like a kite. I mean, a rhombus is really kind of a special kite, but in this case, where all four sides are the same. So to find the area, notice the marking here. The single hash marks here on the horizontal line means that each side's equal, and likewise up here, the double one means that these are equal as well. So to find the diagonals, the first one here, diagonal 1, the vertical one, is 7 millimeters plus 7 millimeters, or 14 millimeters. The second diagonal is 4.5 plus 4.5 millimeters, or 9 millimeters. Now we can plug those into our formula. 1/2 14 times 9, half of 14 is 7. 7 times 9 is 63 square millimeters. Number 9 asks us to calculate the area of the trapezoid. Area of a trapezoid, you remember, is 1/2 the height times the sum of the bases. Now notice we can see the two bases, 20, and then down here 20 plus 9, or 29, but we don't know the height. So once again, we're going to have to use the Pythagorean theorem to find h. See the little triangle here in blue? I have a side of h, a side of 9, and a hypotenuse of 15. So that means that h squared plus 9 squared equals 15 squared. Multiply these out, and we get h squared plus 81 is 225. Subtract 81, and h squared is 144, so that means that h is the square root to unsquare it. 144 is 12 centimeters. Now, our two bases, remember, one is 20, but the bottom one is 20 plus 9, or 29. So now we can plug everything into our formula. 1/2 the height, which is 12 centimeters, and the two bases 29 plus 9. And so we get 1/2 of 12 is 6 times 49, or 294 square centimeters. And number 10, they want us to write the most precise classification of the quadrilateral with the given vertices. So we begin by plotting these points. The first point is -4, 1, so that's 4 to the left from the origin and up 1. Number 2 is -1, 4, so that's 1 to the left and then up 4. And number 3 is 2, 1, so 2 to the right, up 1. And finally, -1, -4, so we go back -1 to the left and then down 4. And there's our drawing. Now, looking at it, we can imagine that looks like it might be a kite. It's not a rhombus. The sides don't appear to be equal, but we can check that all out. So we're going to use I'm going to use, instead of the distance formula, I'm actually going to make little right triangles on each of these sides to find the lengths. So for example, here I notice it's 3 up and 3 over. That'll also help me find my slope. And then over here, this side is 3 and 5, 5 down and 3 over. And then notice over here, it's going to be the same, 3 and 3. So I without even calculating, I know these sides are going to be equal. 3 squared plus 3 squared is S1 squared, and likewise here. So without even calculating, I know they're going to be equal. And likewise down here, the same triangle. So I could actually already conclude in my mind that these is a kite because it has 2 consecutive sides. But let's do the math anyway. The one sides that are 3 and 3, 3 squared plus 3 squared equals S1 squared. So that means 9 plus 9, or 18, is S1 squared. So side 1, these 2 sides on top, are the square root of 18, or about 4.24. The key thing though is they're the same. That has to be the true for being a kite. The next one is 5 squared plus 3 squared, our bottom sides. And so we have 25 plus 9, or 34, equals S2 squared. So S2 is the square root of 34, or about 5.3. But once again, what we're looking at is just to make the point that these 2 sides, the bottom sides, are the same. So we have 2 pairs of consecutive sides. Therefore, we can conclude that the figure has to be a kite. Figure 11, they ask us to find the area of the figure. Well, you'll notice that it's irregular, so the first thing we're going to do here is divide it into 3 rectangles. So I'm going to draw a line here and mark out area 1, another one here, area 2, and then area 3. Now all I have to do is find the area of each rectangle, which is just base times height, and then I'm going to have my, I can add them together to find the total area. So the first one's pretty easy. We can see it's base times height, or it is 5 times 7. When we come to the second one, I put down 5 times 14, maybe wondering where did I get that? Well, notice here on this one side I have 10, and we know that that's 5. So if this whole thing is 10, that means that's 5 too. That's where I get my side here. And then this part here is 7, and this is 7. So notice I have to add those together, and I get 7 plus 7 is 14, and there's where I get my 5 times my 14. And then my last one, again, is 5 times 17. Here I have my 5, and on the bottom I have 21. So 5 times 21, 105 meters squared. And so to find the total area, we simply add those up, 35 plus 70 plus 105, and our area is 210 square meters. And number 12 is actually a fairly easy problem, although I find students lots of times make it harder. They'll try to split this figure up into right angles and find the sides and do things, but you need to remember in this case that the figure looks like it is a rhombus, or at least a kite. And in this case, the area is simply 1/2 the diagonals. So we don't need to mess with finding these sides. We just need to find the diagonals. So we just connect a point from vertices to vertices. So notice from here to here, D1, count the squares, 1, 2, 3, 4, 5, 6, and the D2 count from there to there. So D1 is 6, and D2, if you count the boxes here, is 10. So we plug those in, and we end up with 1/2 of 6 is 3, and 3 times 10 is 30 units squared. So when you get this problem in the test, don't make it harder than it is. You just need to find the 2 diagonals. You don't need to worry about finding the side on this one. In number 13, we're shown a simple parallelogram, and we're asked to find out what error our classmate made. They calculated the area to be 48 feet squared. So we look at the figure and ask, how would they have gotten 48? Well, you can see that they obviously multiplied 8 times 6. That's 48. However, that's actually the base times the side, not the base times the height. And a parallelogram is not the base times the side, it's the base times the height. So the correct area is 8 times not 6, but 8 times 4, or 32 feet squared. And so the area of the parallelogram is 32 feet squared. Remember, on the test, part of the question is to explain your classmate's error. So you're going to need to write a sentence and tell me what the error is if you want to get credit for this problem. Number 14 again, they give us 3 points and they're going to make a triangle, and they want to know is it equilateral, isosceles, or scalene. Now notice you're going to draw it, but you have to include calculations and reasoning. You will not be able just to say, well, I can see by just looking at it. We need to see your calculations and your reasons to give you this answer. So first off, let's plot it. 2 to the right and 2 down is A. B is -1 left and 2 up. And then C is 5 to the right and 2 up. And there's our triangle. Okay? So all we're interested here is the sides. So we just need to find the sides. So I'm going to use the distance formula, and notice for AB, my x value is 2 minus -1, and my y is -2 minus 2. So I end up with 3 squared plus -4 squared, or the square root of 25, which is 5. So that length is 5. When I look at BC, I can just count the squares across. 1, 2, 3, 4, 5, 6, or I could do the x values. 5 minus -1 is 6. And then likewise on the last one, I do it again, and I'll have 2 minus 5 and -2 minus 2, and we end up with the same as we had for AB, or 5. So at this point we notice that we have 2 sides that are the same, so that means this is an isosceles triangle. By the way, we could have also done it, if you don't like the distance formula, you could have also made little triangles and used Pythagorean theorem. You get the same thing. Notice 3 squared and 4 squared equals 5 squared, and over here 3 squared and 4 squared again, 9 and 16 square root of 25. Sometimes it's easier to visualize, particularly on a coordinate plane, to draw the little triangles and use that instead of the distance formula. In number 15, we're asked again to graph and label a triangle. And then this time we're going to calculate the perimeter and the area of the triangle. So first off, -4, 6 means I go 4 to the left from the origin and up 6. B, 2 minus 2 means I go from the origin 2 to the right and then down 2. And C is 2, 6, so 2 to the right and up 6, and there's my triangle. I can tell from the coordinate plane it's a right triangle. Notice because it has a horizontal and a vertical line, so that's going to make that a right triangle. Now, let's start with the perimeter. Let's find the lengths. First of all, AC, the top of it, I can simply count the squares. 1, 2, 3, 4, 5, 6, or I can subtract the x values. 2 subtract -4 is 2 plus 4, or 6. Likewise for BC, BC or CB, I could count the squares again and count that there's 8, or I could do the y values. 6 minus -2, or 6 plus 2 is 8. For the last one, though, we're going to use our since this is a right angle, we'll use our Pythagorean theorem. So we're going to have, if I use the distance formula, I end up with 6 squared plus -8 squared. I could have just used the triangle here and recognize it's 6 squared plus 8 squared. So 36 plus 64, AB is a square root of 100, or 10. Some of you might have recognized that this is actually a 3, 4, 5 triangle. If you take 3, 4, 5 and multiply it by 2, you get 6, 8, 10. So some of you may be able to take a shortcut on that. So now we simply have to add up the perimeters to add up the sides. So 6 plus 8 plus 10, and I get 24 units, and that's my perimeter. Now to find the area is 1/2 the base times the height. Now in this case, because it's a right triangle, my 2 sides are my base around the right angle are my base and height. So this is simply 1/2 6 times 8, which is 24 square units. Notice the perimeter is units because it's distance, but the area, even though the same number, is measuring the number of squares, 24 squares, and that's our area. In number 16, we're going to plot a quadrilateral, and they want us to know the most precise name for the quadrilateral. And again, we have to give calculations and reasoning. We just can't say, oh, it looks like this to me. So let's plot it first. First point is 4, 1. So from the origin, count 4 to the right and up 1. Point 2 is 0 minus 2, so we stay at there, no right or left, and just go down 2. Point C is negative 5, negative 2. That means 5 to the left and then down 2. And the last point, negative 1, 1, means 1 to the left and 1 up. And there's our parallelogram. Okay, we can see it's a parallelogram, but now we got to prove it. We also got to make sure that it's not a square or a rectangle, although we can pretty much see it's not going to be a square or rectangle. We don't see right angles, but we will have to measure its side to make sure it's not a rhombus. So let's start by finding the slopes just to verify it's a parallelogram. I notice here I'm just drawing my little slope triangles. AB is 3 over 4. BC, you notice, along the bottom, it doesn't go up or down. It's 0. The slope is 0. And then on the other side here, CD, we have 3 over 4 again, and DA is 0. So notice that these two lines, that AB and CD have the same slope, so they're parallel. Likewise, the top and the bottom lines both have a slope of 0, so they're parallel. So as a result, we can conclude that this is at least a parallelogram. 2 pairs of parallel lines makes it a parallelogram. But we need to check the side lengths just to make sure it's not a rhombus. So, one last thing. I noted here that if you multiply the two sides together, 0 times 3 over 4, they're not opposite reciprocals, and when you multiply them, you don't get negative 1. So we recognize it's not a right angle, so this is not a rectangle. So now we need to check the segment lengths to see if it might be a rhombus. Well, notice, let's find the length of the sides. First of all, I can look at the bottom here and just count the squares and see that it's 5. Or I can count 0 subtract minus 5 is 5. So that's 5. And I notice DA at the top is also 5. I can count them again. So let's look at what the other sides are. Well, notice these sides are, if I do the distance formula, 0 minus 4 and that, I get negative 4 squared and negative 3 squared. Notice I could have just looked at the triangle and realized this is 3 squared and 4 squared, or 25 and 5, and they're both the same. Although if I were really paying attention, I'd have gone, 3, 4, 5 triangles. So now we found that all 4 sides are the same. So we can conclude this is not just a parallelogram. The most specific, precise name for this is that it is a rhombus. Now the last thing we want to do is find the area. Now I'm going to go ahead and find the perimeter anyway, even though the question doesn't ask me. But you recognize already that all sides are 5, so if I add 5 plus 5 plus 5 plus 5, or 4 times 5, I've got 20 units. When I come to find the area now, I know the base is 5, but what I'm missing is the height. So I can just drop a perpendicular from one side to the other, and I can see that the height is 1, 2, 3. So my area is the base 5 times 3, or 15 squared. In our last problem, they give us a rectangle, but they ask us to use the distance and slope formulas to prove that this is actually a rectangle. So the first thing we're going to do is show that the opposite sides are congruent. That's one thing that's true in both a parallelogram and a rectangle. So first of all, I can use the distance formula, or I can use my little triangles here and realize that this is a 3 by 3 triangle. So 3 squared plus 3 squared, or 9 plus 9 square root of 18. And I could either leave it as square root of 18, or I can simplify it to 3 times the square root of 2. We're just wanting to show that they're equal, so sometimes you might leave it as a square root of 18. G of h on the other side, the side I think is equal. Notice once again, I have a 3 and a 3. So I know I'm going to get the same calculation, or square root of 18, or 3 radical 2. So EF and GH are exactly the same, which has to be true if it's a parallelogram. But now we need to prove that the other two sides are the same as well. And so we'll work on that. Again, I can use my distance formula, or I can simply make a little triangle and count and realize this is a 6 by 6 triangle. So 6 squared plus 6 squared, I get 36 and 36, or square root of 72, or 6 times the square root of 2. I look at the other side and realize, it's the same, 6 and 6. So these two are sides. So now I've shown that not only is EF the same as GH, but FG is the same as EH. And so they have opposite sides of the figure are congruent. This means that my figure is a parallelogram, at least, and maybe a rectangle, but to be a rectangle, we're going to have to show that these are right angles. To do that, we're going to need to look at the slope. So my little triangles come in handy again. Notice the slope of EF is 3 up 3 over 3, or 1. And the slope on the other side is also up 3 over 3 is 1. So these two lines are parallel, whereas these are down 6 and over 6, or minus 1 and minus 1 again. So that just shows us again that opposite sides are parallel, verifying that we do have a parallelogram. But are they perpendicular? To be a perpendicular, the two slopes have to be opposite reciprocals, or one way to show that is to multiply them together and see if you get -1. So the slopes of the parallel, but I also want to see that they are opposite reciprocals. Okay? And so the way you would do that is, if I were to draw this here, I would take one of these and say, okay, 1 times -1 equals -1. And if the two slopes are, when you multiply them, give you -1, they are opposite reciprocals. And then that proves that all 4 of these angles are right angles, and in which case that means we have ourselves a rectangle. All right. Thanks a lot for going through the review with me. Hope you do well on the test. Have a good day.